Welcome to this demonstration for constructing and interpreting a confidence interval for a single population proportion. Our context for this example is, again, our Hamilton Accountable Care Organization. This time, we're interested in investigating the proportion of beneficiaries who smoke. And we're asked to construct an interval estimate for this beneficiary population proportion who smoke. We're going to use a 99% confidence interval here in order to have a very firm estimate of where we think the population proportion resides. So here, if we look at our Hamilton ACO data and we provide some descriptive statistics, we know that out of the 3,185 individuals, 540 of them report smoking. So let's extract that information here. Our number who smoke is equal to 540, and our sample size is equal to 3,185. Okay, so the first thing we want to do is to construct or estimate our sample proportion, which we're going to denote as P bar. P bar is just equal to X over N, and so that is simply equal to 540 divided by 3,185, which gives us 0.170. All right, so we have our point estimate, and now we need to think about the rest. How do we construct the actual interval? And to do this, we're going to use information about our assumed distribution, in which case, in this case in particular, we're going to use the standard normal. And recall from lecture that I talked about the fact that the sampling distribution for our sample proportion is approximately normally distributed, so long as our sample size is sufficiently large and we don't have too rare of events, and that conforms here. So we're going to use the standard normal distribution in this case, and because we're doing a 99% confidence interval, let me just come over to our lovely picture of our standard normal distribution here. What we're going to be doing is we're going to be finding the values of z corresponding to 0.005 in each of the tails. Okay, again, the sum of 0.005 in each tail is 0.01. 1 minus 0.01 is 0.99, which corresponds to the idea of doing our 99% confidence interval. All right, so let me come over here and actually write this out explicitly. So again, I like to use shorthand of CI for confidence interval. So our confidence interval consists of three pieces. It consists of our point estimate, P bar, plus or minus our value of z corresponding to our 99% confidence level, which we can denote this way. And remember that the standard normal distribution does not have any degrees of freedom, so we don't have to worry about that. And then our third term is our standard error for the proportion, and we're going to estimate that using the following expression: P bar times 1 minus P bar divided by n, where n is our sample size. So these are the three components that go into our confidence interval estimation. And now we can put the pieces together. So we have our, and I'll switch pens for some variety here. So we have 0.17, which is our point estimate, plus or minus. Now, to find the value of z, we could go to either a standard normal table in a textbook, or we can use Excel in order to arrive at the value. And there's more details in the lecture about the particular statistical function to use. For the sake of expediency, let me go ahead and write down what that z value is here. Specifically, it is going to be 2.576. That's going to correspond to the value on the standard normal distribution, such that we have 0.005 in the lower tail and 0.005 in the upper tail. All right, so let's put this last piece together here. We've got 0.170 times 1 minus 1.170 divided by 3,185. And the result of that is an estimate of, lower bound estimate of 0.1491. to 0.1909. That corresponds to 0.170 minus 2.576 times this term, that's the lower bound, and 0.170 plus this term, that's the upper bound. For interpretation purposes, what it says is that the population proportion that smokes in the Hamilton ACO beneficiary population is estimated to be between 0.1491, or roughly 14.9%, and 0.909, or roughly 19.1%. Okay, so this is a 99% confidence interval, which means that it is really the widest interval that we are likely to estimate given that high degree of confidence. If we were to drop our confidence level, the interval estimate would be narrower, a smaller interval. So the last piece of this question in the demonstration is that kind of national estimates suggest that for the overall Medicare beneficiary population, 9% of beneficiaries smoke. We can use interval estimates to also allow us to make some inferences about how our population differs from some benchmark. In this case, you'll notice that 9% sits far outside of our particular interval, suggesting that we are likely significantly higher relative to the national proportion. Okay, this concludes our demonstration for constructing a 99% confidence interval for a single population proportion.